Hello, welcome to part 5 of Chemistry Paper 1. Let's get started. So 8. Covalent substances can be simple molecular covalent or giant covalent. So simple molecular covalent or giant covalent. Ammonia is a simple molecular covalent substance. Which of these is most likely to be a set of properties for ammonia? So melting point in Celsius. So remember, simple covalent, low melting point is low boiling points, don't conduct electricity. Okay, so melting point 1713. No, it doesn't sound like a simple covalent. Minus 78, yeah, maybe. Minus 33, maybe, yeah. Minus 39, 357. No, not really. And this is too high too, so it's B. Okay, this is quite an easy one. Sometimes they trick you a little bit. But also, other than the low boiling and melting point, it does not conduct electricity. So simple covalent does not conduct electricity. Okay, next one. Ammonia, NH3, is made by reacting nitrogen with hydrogen. Write the balanced equation for this reaction. So let's start actually just with the symbols for the actual elements. Nitrogen, remember it's a gas, so it's N2. Plus, we'll balance it afterwards, plus H2 goes to, not equals, now it goes to NH3. So let's tidy that up now. Okay, so we've got one end, two ends, put a 2 in front of this. 2 times 3, so we've got 6. Put 3 in front of this, everything's balanced. That's actually quite a nice one to do. Okay, so 2 marks. One mark for the elements, 1 mark for the balancing there. So you can't balance, still get 1 mark. Oxygen O2 is a simple molecular covalent substance. Draw a dot and cross diagram for the molecule of oxygen. Okay, so dot and cross, we've got 2 oxygen, just O2. So O for oxygen in the middle, another O for oxygen. Okay, that's not a shell. So it's covalent, so let's draw a circle and then an overlapping circle because it's covalent. Okay, so oxygen. Now, if you can't remember, okay, the number of oxygen, we can go to the periodic table. Okay, it's always at the back. Oh, I meant to vote. 28. Right, oxygen, just flip this round. Right, so oxygen's over here, atomic number of 8. So think about it, it's 2, 6. Okay, 2, 6, it's electronic structure. Okay, flip it back. Okay, so what it's going to do, okay, it's going to, because it wants to get a full outer shell, it's going to share 2 pairs of electrons. See where the word dot and cross diagram comes from. Dots and crosses. Okay, and we'll put the X on this one. 1, 2, 3, 4. 1, 2, 3, 4. We're only showing the outer electrons. Don't worry about the inner electrons, just about the outer ones, unless we're told to draw full electronic configuration. For bonding, we only need to draw the outer. This one, 1, 2, 3, 4. It doesn't really matter where these go. There's a convention to draw them in pairs like that. Okay, you won't lose marks. Okay, it says so don't worry. So it shows 2, O2, so because it wants to get noble gas configuration. Okay, it wants to be as stable as it can. So when it's sharing 2 electrons from the other oxygen atoms, neighbor, then it's actually they both get noble gas configuration. And that diagram gives you 2 marks. It's always one worth remembering how to do. So let's have a look at this one. Figure 8 shows the arrangement of carbon atoms in diamond, graphene, and fullerene. A fullerene, C60, 60 carbon atoms. Consider the 3 substances. Explain in terms of their structures and bonding, their relative melting point, strengths, and abilities to conduct electricity. Okay, so let's have a think. Let's think about diamond first of all. So diamond, okay, has each carbon atom joined to 4 others. Okay. It's got all its bonds complete there. Joined to 4 others. Okay, so it's a giant covalent structure. It's not simple, it's a giant covalent structure. They're actually covalently bonded. Giant covalent structure. Okay, so diamond has no free electrons. Okay. So diamond has a high melting point. Let me just put the screen down a little bit to right. So you've got quite a lot of space there if you need it. Might be able to get it. So it has a high melting point. But does not conduct electricity. Okay, so graphene is the next one. It's like graphite. So graphene, okay, is also a giant covalent. Is also a giant covalent. So has a high melting point. Okay, so it has a high melting point, but also has delocalized electrons, but also has delocalized electrons allowing it to convert. Conduct. Yeah, don't worry, make a mistake down. Just do what I just did there. Just rub it out. Just cross it out. Don't rub it. Yeah, don't worry about anything. Fancy, just rub it out. Just or cross it out and start again. So if you conduct, start your just only one word again. Don't start the whole answer again. Just start one word again to conduct electricity. Because yeah, sometimes obviously if you exam a long time, your brain is just gonna kind of stop working a bit. Even if you feel used to it, like me. Like if you've been doing, if you go for an exam. When you start to make real mistakes, just be careful and always look back at your answers, make sure you haven't written silly words, and just cross them out and just put the word you want. That's fine. Now we get to conduct. So we go to it again, to conduct electricity. Okay. So I mean, always good. Yeah, look, read back at your sentence. I was reading it back. You won't be talking like me, so you have to concentrate a bit better. Yeah, now I get to conduct. Don't worry about a messy answer. Do not worry. Okay, as long as I can read it. So graphene. Okay, that's one that's not as familiar. Graphene or a fullerene. You know, graphene is like graphite. A fullerene, not as well connected as diamond, is it? So it won't have quite a high melting point. So graphene. So graphene. Sorry, graphene we just talked about. I'm sorry. A fullerene. So fullerene. So fullerene. Last one. It's like a football shape. So fullerene. Okay. Actually has weaker forces. So it has weaker forces, not as many bonds, there's weaker forces between atoms than diamond. So its melting point will not be as high. As we've got some room down here to be as high. So in fullerene, there are only free electrons, ones that are free to move, across the surface. So only conducts electricity over the surface. Okay. It's kind of in between, isn't it, though? So fullerene's kind of in between diamond and graphene, okay, because they're all what's called allotropes of carbon. Okay. Number 9. A student placed a piece of metal P in a test tube containing excess dilute sulphuric acid. The student repeated this with 3 other metals, Q, R, and S. All the pieces of 4 metals were the same size. The student recorded the observations until each metal had reacted with the acid for 2 minutes. The observations are shown in figure 9. Okay, so we need to use this information to put the 4 metals in order of reactivity from the least reactive to the most reactive. Okay, so let's have a look at what they do. Bubbles produced very slowly, some metal remained. Bubbles produced quickly, no metal remained. Bubbles produced slowly, no metal remained. Bubbles produced very quickly. So, okay, so which one is the fastest one? Very quickly, 1. Fastest, bubble 2. And P is the slowest one. So most reactive was S, then it went Q, then it went R, and finally the last one, P. Okay, so it's just more of a reading exercise there. Okay. Complete the diagram below to show how the student could add to the apparatus to measure the volume of gas produced in 2 minutes. Okay, so what you could use is a gas syringe, will be easiest in the time given an exam. Is a gas so a gas syringe, just a pipe attached to. Right, it does look looks like a massive syringe, so you get on a needle, but it hasn't got a pointy bit. Right, so this is a gas syringe. It would have little markings on it to show you the measurements. Gas syringe. Okay, so you've got 1 mark for delivery tube. Let's put in a little bit more. This is a delivery tube. That's a gas syringe. That's actually all we need to do there. Okay, it doesn't. So just complete the diagram, labeled diagram. No writing is actually needed there. Okay, 2 marks. So delivery tube and a gas syringe. So when iron reacts with copper sulfate solution, solid copper is formed. 2 possible equations for this reaction are COSO4, so copper sulfate plus iron goes to copper plus iron sulfate. 3 CuSO4 plus 2 Fe goes to 3, which is different proportions there. There's the same reaction, different proportions. It was found that 10 grams of iron powder reacted with excess copper sulfate solution to produce 11.34 grams of copper. Carry out a calculation to decide which equation, A or B, represents the reaction taking place. So Fe equals 56, copper 63.5. Okay, so let's just try. We'll do process of elimination, only 2. Okay, so we've got 10 grams of iron powder. Okay, so we've got 10 grams of iron powder. So we've got iron. So let's have a look. So formula mass of iron. So atomic mass of iron. So atomic formula or mass. Equals 56. Okay, so we've got moles of iron. Okay, so we've got 10 grams of iron powder. So 10 divided by 56. Let's do it with my calculator. Everything's live here. It's already in grams, so I don't need to convert it. So that we talked about earlier. So moles of iron, 0.1, so it's 179. We'll go for that for a minute. It's not our final answer, so don't worry about rounding up there for a minute. If you did, you get error carried forward, you still get the marks. Okay, moles of iron, that'll give us 1 mark. Okay, so then that one, so how many, so copper is 63. So let's see if we've got the same moles of copper. So moles of copper, this is quite a tricky question, but we're just doing trial and error, trying the first one out. Moles of copper, 11.34 over 63.5. If this equals the same number as this, it is a reaction A. So we've both got a, again, we're doing a ratio here. 11.34. Divided by 63.5. Yeah, same answer. Okay, 0.179. So the ratio is 1 mole of iron, so 1 mole of copper. So reaction A. If it hadn't, it would be reaction B. Okay, so there's only 2 reactions, just try one of them out. Okay, so C, acid solutions contain hydrogen ions. Aluminium reacts with dilute hydrochloric acid to form a solution containing aluminium ions, Al3+. Complete the balanced ionic equation for this reaction. So aluminium reacts with hydrochloric acid. So we've got H plus there, so we need Al. Okay, and Al plus H2. Then we need to balance it. So this again is a bit of trial and error. Okay, 2Al. 6. This is quite a difficult one, really. Okay, so that'll give you the 2 marks. D. The hydrogen ion concentration in solution is decreased by a factor of 10. State how the pH of the solution changes. So pH, so how the pH changes. So the pH goes up. So it becomes less acidic, okay, or closer to neutral. So pH goes up. So I will go back to that. So, right, so let's go seeing what the next one was. Calculate the mass in grams of a hydrogen atom using the data below. Okay, this is interesting. Okay. Relative atomic mass, H is 1, which is 1. And Avogadro constant, so that's 1 mole of atom, 6.02 times 10 to the 23. Okay, so 1 gram, so this is really about definitions. So 1 gram of hydrogen equals 6.02 times 10 to the 23 atoms. Okay, so all we need to do, okay, is let's go to the next one. All we need to do is mass, so 1 gram and that many. So 1 gram over 6.02 times 10 to the 23. Okay, so that's what we need to put into our calculators. So 1 over that, obviously it's going to be very tiny, it's only 1 hydrogen atom as well. So let me type that in. Okay, so 6.02, okay, EXP 23. Okay, don't calculate. That's a very big number. Okay, so let's just go back there for a minute. So 1 divided by, and then put in brackets. 6, but yeah, you might need to put that other one in brackets at the bottom there. 23, I'll put it in brackets in a moment, we'll have to work this out. Okay. Right, so what we get, so yeah, put that in brackets, that's why I just had on my calculator. I need to put that in brackets, so I tried it for you. It's 1.66 times 10 to the minus 24, that's grams, okay, because that was grams there. So 1.66 times 10 to the minus. Again, that's quite tricky to think about. Okay, so it's not difficult to do, but you can think about that one. Let's go on to our last question then. So the concentration of dilute sulphuric acid can be determined by titration with sodium hydroxide solution of known concentration. 25 centimeters cubed of dilute sulphuric acid was measured out using a pipette and transferred to a conical flask. A few drops of methyl orange indicator were added to the acid in the conical flask. Sodium hydroxide was added to the acid for a burette until the indicator changed colour. The titration was repeated until two concordant, it kind of goes together, not an anomaly, results were obtained. Describe the colour change seen at the end of the titration. Right, so if it went into acid, okay, so we're actually going to outline this bit. Okay, it goes from pink, it's in the acid. If you've forgotten the colours of methyl orange, that's the thing to revise. Okay, so pink to, it's kind of goes like an orangey red. Okay, so pink to orange. Okay. A brief report of the practical method has been given above. Further detail can be added to this method, okay, to ensure that anyone following the method will obtain, so get, an accurate result. Explain two details that could be added to this practical method to ensure an accurate method is obtained. Okay, so there's a few different things we can do right here. So read the volumes from the meniscus. On the meniscus, okay, to obtain accurate volume. Okay, so one. Another one would be about the color change. So place the conical flask on a white tile to ensure accurate color change readings. So there's lots of other things you could do, like swirl the flask around. Okay, there's a number of things you could do there. Okay, so let's think about anything sensible. There's actually quite a lot of good opportunity for marks. Okay, in the titration, 25 centimeters cubed of dilute sulphuric acid reacted with 24.25 of 2 mole sodium hydroxide solution, NaOH. Calculate the concentration of dilute sulphuric acid, H2SO4 in moles per dm cubed. Right, so this is write a few key points down. Okay, so we've got right, so we've got, let's look at what we've got with information. Actually, we don't know this, so we know that one. So there's some things we know, some we don't. So 24, the things we know down first, 24.25 cm cubed and 0.2 mole dm cubed, okay, of sodium hydroxide. Okay, so let's work out the moles. So moles of NaOH. Okay, 24.25 times 0.2, and to put that into decimeters, we divide by 1,000. Okay, so that is going to be quite a small number there. So 4.85 times 10 to the power minus 3, 5. So concentration of H2SO4 equals 2.425, it's already converted, times 10 to the minus 3 times 1,000 over 25, give us 0.097 moles per dm cubed. Okay, 0.097 moles per dm cubed. Right, last question completely then. The concentration of some dilute sulphuric acid is 0.25 moles per dm cubed. Calculate the concentration of sulphuric acid in the solution in grams per dm cubed. Relative formula mass of H2SO4. So concentration equals 98 times 1, we have to convert this time, 24.5. Okay, grams per dm cubed. Okay, that's the end of that paper. So that's the answer, 24.5. So thank you for listening. Got all the way through this paper. Hope to see you in another science paper. Thank you for listening and goodbye.